Hi, algebra students. We're starting a new section today, new chapter. We're going to be working with exponents. So I'm going to share my screen and you can see the presentation. All right, we're going to play from the start. So it says with a partner in a class, or if you're working at home, you're doing this on your own, complete exploration 1 on pages 168 and 169 in your journal. So pause the video, grab your journal and try those problems because there are some important things you should notice about what's happening when you multiply. Let's see, here are things here. When you multiply two powers with the same base, or if you find a power of a power, etc. So you should try those and then come back. All right, welcome back. Let's look at the next slide. You have some vocabulary to write down in your journal on page 170. So a power is an expression involving a number or a variable with an exponent. Remember, this big number here is called the base. The little number is called the exponent. Scientific notation is a number in the form a times 10 to some power, where this number here is something between 1 and 10, but it's not equal to 10, notice that, but it can be equal to 1. And b is an integer. All right, we're going to jump right into extra practice. Let me go back a slide here, actually, before we start that. You have several properties that you should read about on page 171. They're all the properties of exponents. You need to remember these. For example, if you multiply by the same base, you add the exponent. If you are dividing by the same base, right, like x to the fifth divided by x to the second, you subtract the exponents. If you have a power inside of parentheses and an exponent outside, you multiply the exponents together. And if you have things being multiplied inside of parentheses with a power on the outside, each thing inside gets that power that's on the outside. And same with fractions. So we're going to look at some of these. So let's look at number 1, first of all, on page 172 in the journal. So number 1 is the 0 power property, which is really kind of cool. I'm going to grab my pen. So this is number 1. We have 3 to the 0 power. Now, hopefully you read on page 171 that anything, or excuse me, on page 170, that anything to the 0 power is equal to 1, whether it's 256 or x or -3, anything to the 0 power is 1. All right, let's look at number 5. We have 2 to the -3 divided by 5 to the 0, right? And it also says in the instructions on these that you are supposed to evaluate, and in general, you're trying to write things without negative exponents. You're usually trying to rearrange things so that you can get rid of the negative exponents. So I'm going to leave 2 to the -3 alone for a minute. And I'm going to rewrite my 5 to the 0 power as just 1. Now you have a property on page 170 that says for negative exponents, if your exponent is negative, it's the same as 1 divided by that number to a positive exponent. What I like to think of is as this number crosses the division sign, the exponent changes from negative to positive or positive to negative. So when this moves down, I'm left with just a 1 on top, because I could think of this as being 1 times 2 to the -3. Now on the bottom, I have the 1 that was there already, and now I'm multiplying it by 2 to the -3, or excuse me, 2 to the +3 when it comes to the bottom. Oh, that's really messy looking. But it's really just equal to 1 times anything is just the anything, and it's 2 to the 3rd. Okay, we can keep simplifying that. We can do 2 to the 3rd power. It's 2 times 2 times 2, which is 8. So this 2 to the -3, or 5 to the 0, turned into 1/8. All right, let's look at another one. Let's look at number 10. This time we have a to the -8th power. And the directions say, write your answer using only positive exponents. All right, here's what we need to remember when we see a to the -8th. That's the same thing as being over 1, just like if I have the number 3, the number 3 can be written as 3 over 1, because 3 divided by 1 is just 3. So again, I can take this, I can move it to the bottom of the fraction so that the exponent changes sign. I'm still left with 1 in the numerator, and now in the denominator, I have 1 times a to the positive 8th, or just 1 over a to the 8th. So one thing that you'll see that you can do is kind of fun. Let's say I have 2 to the negative 3 over a to the negative 5. All right, things that you can think about. When this goes to the top, that exponent becomes positive. When this comes to the denominator, its exponent becomes positive. So in this case, I would end up with a to the positive 5 in the numerator and 2 to the positive 3 in the denominator, or a to the 5th over 8. Okay. Similarly, if you remember when you're solving equations, if I have something like x minus 3y equals 7, if I were to take this negative 3y to the other side, it changes sign. It'd be 7 plus 3y. So same idea. When you're crossing that division sign, the exponent changes power. Notice numbers don't change signs though. Like if I have 1 over a number like negative 2, I can't move that to the numerator and make that a positive number. Okay, it only works when we're working with exponents. All right, let's go back. We're now looking at number 11. Number 11, we have 6 times a to the 0 times b to the negative 2. Okay, so things we're going to remember is that, I'm going to grab a different color here for a minute. We're going to remember that anything to the 0 power is 1. I see a negative exponent here, so I'm going to move that to the denominator of my fraction. All right, right now we don't see a fraction, but we're going to make one. So this is going to turn into 6 times, remember these are all being multiplied, 6 times 1. But I'm taking this and moving it down below so that I can get a positive exponent. So it's going to be b to the positive 2. So I keep simplifying. Remember, my 1 came from here. A to the 0 power was 1. So 6 times 1 is 6 over b to the second. All right, let's look at another one. Let's look at number 16. This time we have negative 2 to the 7th over negative 2 to the 5th. So remember the rule that says if you have the same base and you're dividing, you subtract the exponents. So our base here, notice they both are negative 2. So I'm going to rewrite this as negative 2 to the, and I always subtract where there's more. So in this case, 7 is bigger than 5. So I'm going to keep it in the numerator and make this 7 minus 5. If it had been reversed and I had a 5 here and 7 below, I would have made it 1 over negative 2 to the 7 minus 5. So go where you will end up with a positive exponent. So I keep going. This is now negative 2 to the second power. It's kind of a scratchy looking negative 2. So remember, when you see a squared or a second power, you're taking that number and multiplying it times itself. So negative 2 times negative 2 results in a positive 4. All right, let's look at number 18. Number 18 this time, we have q to the 5th inside and an exponent of 3 on the outside. So Properties of Exponents says if you have something raised to a power inside and there's an exponent on the outside, that these two exponents get multiplied. So this turns into q to the 15th. If you think about it, if you wrote it out longhand, this would be q to the 5th, so I'd have 5 q's being multiplied times each other. And if I did that to the third power, I had 5 q's, then 5 q's, then 5 q's, for a total of 15 q's that were being multiplied. All right, let's look at 19 this time. Number 19, we have a to the negative 4 And that is all to the second power. Again, exponent on the inside, exponent on the outside of the parentheses. I multiply the exponents. So that turns into a to the -8th. -4 times 2 is -8. I don't want a negative exponent, so it's going to move to the bottom. When it moves to the bottom, I'm left with a 1 in the numerator, and this becomes a to the +8 in the denominator. All right, one more practice problem. This is number 20. This time we have c to the 4th times c to the 3rd divided by c to the 6th. All right, so we're going to use a couple different rules here. The first rule we'll use in the numerator. When you're multiplying by the same base, you add the exponent, right? This is 4 c's and another 3 for a total of c to the 7th. In the denominator, I have c to the 6th. So now we're going to use the quotient rule, which if I have the same base, in this case my base is c, I subtract the exponents, so this becomes c to the 7 minus 6, or c to the 1st power, which is just c. Remember, when you just have a variable, there's an exponent of 1 there that you don't need to write down. All right, let's look at the next slide. And the next slide is the assignment. It's a worksheet. If you're working remotely, be sure to either print the worksheet or copy the problems onto paper, take a picture of your finished work and submit it through Schoology. Email me if you have any questions. Good luck.